It's a pleasure to be here with you guys. Today I'm going to talk about Congruent Infrastructure Lifecycle at Sky. I'm going to talk about what we do in a department called Content Discovery. So let's go. So I also believe in this, so this is why I tend to do these presentations, and I think we can gain experience of each other. So we developed me very fast. My name is Olivera. Again, I'm a reliability engineering lead. At Sky, I work in several kinds of industries, telco, banking sector, public sector. I did some stuff by my own, and I'm a container freak, I would say. You can contact me. I don't do Twitter, sorry guys, but you can contact me anytime. So a bit more about Sky. So from people here, do everyone know Sky? Yes, I'm not British, so I don't know much about it. Yeah, Sky obviously is a very strong brand in the UK, and Sky brought like products, very old products like Sky News. I grew up with Sky News, in my hometown. We had like satellite TV at the time, and I used Sky News since I was a kid. But we have like Sky Go, Sky Q, Now TV, Sky Broadband, Sky Cinema, and now we have also the mobile option. So it's a very recent product from Sky, and it will be awesome. So we actually have lots of things that we do at Sky, and Content Discovery is actually in the middle of all this. So, so a bit more about Sky. So 30,000 people plus 11,000 customer service agents, and so field area people. So we have HQ London, Munich, and Milan. Revenue 12 billion, 22 million customers. So it's quite big. It's one of the biggest entertainment companies in the world. About Content Discovery. So Content Discovery is so you don't know Content Discovery as a product inside Sky. So it's not like a brand like Now TV. So Now TV has its own team, and that's quite attractive. So Content Discovery doesn't say much, but we do what the words say. We do content and we discovery. This department has around 9 development teams, and we feed metadata to all these services that I just put. Like for instance, if you see a search bar, if you have Sky Q or Sky HD, or if you have Sky Go, if you see a search bar, we actually provide the data to that search bar. If you have again your HD box, all the recommendations that you see on your TV is provided by us. So all the metadata that are injected on these services come from this team, the Content Discovery team. We work with around 100 developers, and I lead with my colleagues 22 reliability engineers and 6 graduates from the Sky Academy, which are great. And we lead this team of reliability engineering inside Content Discovery. Okay? So this is like our DevOps. Yeah, exactly. Search, problem database, all this metadata, it comes from this thing. So in terms of technically aspects, so Content Discovery we handle with around 10 terahertz of CPU capacity, 70 terabytes of RAM, 700 terabytes of persistent disk is around a bit less than 1 petabyte in hard disk and SSDs. We have currently around 4,500 VMs. So in this January, we had around 2,800 VMs. So we are increasing our capacity and our services in a very fast way. And we run around 10,000 Docker containers inside of these 4,500 VMs. We run 100% in Linux on all our services. And we currently provision to OpenStack, VMware, and other. We are quite a VMware shop. Another thing I need to say is that Sky is not like a cloud native company. Do you understand what I'm telling this? So what I'm trying to say is that Sky was not born in the cloud. So all the systems that we have probably were not made to run in the cloud. So we have like VMware, every VMware infrastructure, and we have some legacy systems, and we have lots of new stuff. So we need to be prepared to run on all these systems. So we tend to call ourselves like infrastructure agnostic because we need to run in the cloud on premises in a seamless way. So the business had a challenge for us. Okay, and this challenge can, from the business, come like this. So you can see all this. It's very interesting. Don't know if it says much to you, but I can translate. So Sky is expanding to territories outside of the UK. We have already presence in Germany and Italy, but we want to go more. We want to go whole Europe, and we want to go maybe US, and we want to go to Pacific, EMEA, and this requires a huge expansion in terms of services. So basically, this is a translation from the business to us. It goes something like that. So we need to build and expand all those services. So, well, it's not all those services, but like a subset of the OTT services, which are OTT are the internet exposed services, like Now TV and SkyQ. So we need to build a new territory in less than 24 hours. Okay? And each territory can go from 300 to 800 Docker hosts. We need to be infrastructure agnostic. This is one requirement from the financial officer, because prices can vary depending on the region where you are putting your stuff. So for instance, on New Zealand, if Sky wants to go to New Zealand, obviously we cannot serve our stuff from the UK. And we could use CDN, and we're going to use CDN. But our base system, our hub, is to be much closer to the Pacific than in the UK. So this means that we need to find a proper solution to actually host our stuff in a specific provider on that area. So multi-tenancy approach was the internal requirement, and this can be decided in a very short notice. Okay? In a week or less, we need to be prepared to do the deployment in one day, and in one day we need to be serving to customers. A new territory can go from 10,000 customers to 3 million customers from day one. So before this challenge, we were like what we call like an old model DevOps team. So we had several problems. Okay, we still have several problems. We are trying to tackle them one by one. So we had impact DevOps within dev teams. We had too much operational work. We have senior DevOps expanding file systems and fixing cron tabs and things like that. Every team, because we are in DevOps, these DevOps were in bed on the 9 teams that I just mentioned, which made the problem number 4. So different teams had different provisioning systems. So they were working in silos and doing their own stuff without communicating. Okay? Lack of infrastructure and platform representation and description, so meaning that infrastructure as code was non-existent. DevOps were much more ops than devs, and this is a problem for the most senior one. When you are a junior, you can handle these expand file systems and so on. When you are a senior DevOps, you start getting upset with these things. You want to do cool stuff, you don't want to get expanding file systems and check the LVMs and things like that. We don't want that. So proliferation of all this technology around was not good, and people were upset. Yes, it was a pet zone, but we are changing that. Okay? So now we believe in congruent infrastructure. Okay? So let's talk about congruent infrastructure. So congruent infrastructure is basically like a spoiler alert. Congruent infrastructure is immutable infrastructure, and this is a theme that we have been talking about maybe 2-3 years now, and applying this concept is not easy. Okay? Mainly when you are not a cloud native company. But this paper, the why order matters, doing equivalence in automated system administration, is a wonderful paper. I recommend everyone actually do it. Just grab it and read it. Even if you are not doing immutable infrastructure, it is still very interesting. And this paper actually is the base of our congruent infrastructure that we adopt at Sky. Obviously, there is a Paul Good paper about divergent convergent congruent infrastructure that actually talk about this topic. And John Will is from Docker. He wrote this immutable delivery paper, which actually shaped the way we view congruent infrastructure at Sky. So just a brief talk about like this congruent infrastructure. I want to talk about divergent and convergent infrastructure. So the congruent infrastructure, this one here, actually states that the actual infrastructure, the state of your infrastructure, needs to be the same as the target infrastructure. Okay, so there is no configuration drift. Okay, so this is what it means. There is no configuration drift. And the way to achieve this, you have configuration management tools like Puppet and Ansible that change the way from divergent and convergent infrastructures to a congruent infrastructure. So one more test, you can see that, for instance, again from this paper, you see very interesting ways of understanding how do you see if you have a congruent infrastructure. So if you are rapid, predictable, and you can entirely forget deployments and changes, that probably you are a congruent infrastructure. Also, this paper is from 2002, so it says an hour. I don't believe in that anymore. I think it should be minutes or seconds. Right? Okay? So, in summary, we say, at least in content discovery, we say that everything else other than data can be replaced at every deployment. Okay? This is what we need from infrastructure for us. This is how we want to achieve congruent infrastructure. So this requires transformation on our team. As I mentioned, the DevOps pre-challenge were like not able to scale to the challenge that Sky business wanted. So we understand that DevOps can be a product of continuous delivery and continuous delivery flow directly into the DevOps. When automation is not enough, we adopt infrastructure as code and also a language that actually represents what we're trying to install and deploy. Manipulate infrastructure in our automated repeatable way. This is a prereq for immutable infrastructure. Without this, you can't do anything. We need to talk about golden templates. This is something that we're going to do here. Auto-scaling, elasticity, we need to do that, and we need the discovery of dynamic services. So service discovery is also a key element here. Monitoring, active monitoring, profiling, and log integration is very important. We won't talk about preemptive error detection because it requires a bit more time. We're going to talk about monitoring and how we leverage our immutable infrastructure on the monitoring setup. And yes, we are adepts of microservices architecture. So again, on transformation, we decided a couple of things. So this is not, I'm here trying to explain what we did. It doesn't mean that everyone needs to do it the way that we do, but we stopped using Puppet, we stopped using Ansible. No configuration management at all on the infrastructure side. Okay? We don't write scripts anymore. At least personally, as a DevOps or SRE, you can write your own scripts. No one will tell you that you shouldn't write it. But as a team, we don't use scripts. We use APIs. So if you write a very fancy script that other guys in the team want to use it, transform your script in API so it can be pluggable on other systems. Okay? This is like one of the first laws that we have. Yes, behave as SRE instead of operation engineer. When I talk SRE, yes, I'm talking about Google SRE. We believe that to be a DevOps at Sky, you need to have like some proficiency in a development language. We use mainly Go, but other languages are accepted, and we use other languages. Select one development language for your team. So we, as I mentioned, we do Golang. And select one even visible data serialization language, which was HCL and JSON, which actually is the same. So I could, talking about congruent infrastructure, I can't go further without speaking about Docker. Obviously everyone knows Docker, and we use Docker extensively. And we use it for its main reasons. And the first one is probably the main reason. So we don't care much about the isolation because we are in a virtualization model. So each team has its own set of infrastructure, but the packaging, the application is one of the things that we are most interested in Docker, and how the runtime of the application goes inside of the company. So obviously, this also leverage microservice approach, and the Docker API is interesting. Another one is Terraform. Okay, HashiCorp changed the way we do things. Also, HashiCorp is a very interesting company. It's not great. I think is awesome how they found the way to bootstrap infrastructure. So it doesn't do so well with containers. It works, connect to the Docker API and do things, but it doesn't do the flexibility we want. and we build several providers. So my team build like 3 or 4 of these. Some of them we're going to put on the open source, so the VMware NSX, we put it as open source. Rocket VTM, so Rocket VTM, I don't know, does anyone use this Rocket VTM software? No? Is it virtualization, is a virtualized load balancer? So we made it's a very interesting thing because it has an API, so it's very easy to interact and to do blue and green deployments and stuff. So, and we also use Olivera, and Olivera we created for this also, all for as Terraform providers. So about lifecycle. So our lifecycle is extremely complex. So it's we create Docker hosts and we destroy Docker hosts. Okay? Nothing else. Simple as that. Now to do this, we had to create some complex infrastructure. We had to create a pipeline for the golden image. We had to create a pipeline for CI/CD, which we don't fully control yet. So we are in the way to control it. And we could talk about green and blue deployments, but I don't think we have time for it right now. And how do we bootstrap monitoring? What is Vault OTP that we use, and what is Orly project? Okay. Yes, and we put expiration dates on all of our VMs. So our VMs, after 6 months, they stop working at the Docker container level. Okay? The API cannot receive any remote requests after 6 months. So this forces ourselves and developers to have a life cycle on this VM. So when you do green and blue, you need to make sure that you deploy new infrastructure and you kill the old one. So this gives us this infrastructure as code representation that we want, and we force developers and our own team to actually have the representation of what exists, because if you destroy what exists, you cannot replicate it again if you don't use infrastructure. So the golden image. So we have, this is a description of our golden image. Obviously we use Packer, HashiCorp Packer. Everyone knows HashiCorp Packer? Have you worked with it? Okay, good. This is not actually an HashiCorp package JSON file, but is an appendix of that file that we can actually, so this is all software installed on the golden image. It's a Docker engine, cstat, sysdig, netcat, and the VMware thing that we use for Docker volumes. And that's it, nothing else. We don't use Puppet, again, no Puppet, no Ansible, and we can discuss this a little more. So this is the pipeline for the golden image. So you use Jenkins. Is not my. I don't have any particular preference on this on the CI mechanism, just because everyone in Sky is Jenkins, so just to be like aligned in the structure. We use Jenkins, but there are certain CI and other ones very good. But Jenkins. So starting on this diagram, we actually the challenge was to actually create a golden image that is versioned, that we could actually create one and save it immediately as an AMI, as an OpenStack template or a VMware template on runtime. Okay, so we Jenkins, we just say we instruct Packer. So let's start to deploy this thing. So we create a VMware player because we have this configuration set up. He goes to the internet. So first he goes to Git repo. He gets all the information, all these JSON things. He starts doing his job. Goes to the external repo. We use CentOS, but it could be any other distro. He starts making the OVF image. When that's done, we apply the software inside of it, and then figure another job that actually connects with the vSphere or it connects with other provider that you choose. Okay. Afterwards, we have Terraform that interacts with this stuff and starts creating things. One very important thing to notice here is the etcd or console. So we start using etcd as a service discovery mechanism because at Sky we use lots of Kubernetes also, and we also start using Kubernetes because we stopped using Kubernetes and actually etcd was no more useful to us. So we are changing to console. That console will give us more features out of the box than etcd. And etcd actually changed to v3 now, and actually they changed lots of stuff from v2 to v3 and this is so we use console, and each time that actually we create a new image. This image is the representation of the version is changed on console. So Terraform can actually console and say, what is the latest version? Right? Do you want the latest? Do you want a specific version? Do you want like a test version? Which version do you want to deploy? Okay, we can choose this by Terraform. And this is all automated. Okay. At the same time, we create also a password on our images, and this password is automatically stored in Vault. The password is created at runtime, and then Terraform can actually consult this password if he has access to it. Okay. Also, we use PowerDNS, our DNS system. We actually changed from FreeAPA. FreeAPA was, I can't answer why we use FreeAPA. It was before I arrived this guy, but we found lots of issues with FreeAPA. So we were about to change, and then we understand that we need a DNS that has an API, so we can manipulate API and the DNS very fast. So PowerDNS, we choose PowerDNS because it was a native, because you had a native provider on Terraform, and we also use Kia. Does anyone use Kia here? No, this is old stuff. Actually, it's quite brand new, because this is a DHCP server from ISC. It's the new generation of DHCP servers. But we also use an NSX, firmware NSX as the activate. So this pipeline is a bit different. So this is, we could cut this in the middle. Sorry for the representation of it. So on the left side, if we were to cut this on a vertical way, on the left side we have the workflow for developers. On the right side, we have the workflow for infrastructure guys. Okay? So on the left, you have like you have a Jenkins slave running on into the Docker host that creates more Docker ephemeral containers. And Jenkins, actually, the developers, they can act, they can create their job. So we don't put many rules in terms of CI, but we tell them that they need to deploy their stuff on Nexus. So we don't use Docker registry. Does everyone has bad experience with Docker registry? Because we have bad experience with Docker registry. So we just do Docker registry and use Nexus 3 as Docker repo. So we ask developers, so they should do their lifecycle Nexus. So they commit images to Nexus, and they commit their code to Nexus. Okay? When this is done, we use Nexus as a Docker repo. So they do their builds, they build their code, they compile their code if it's Java, if it's any other thing, and then they commit the image to Nexus. At this point, they read that CD, and actually they check the information that is pushed by Terraform to etcd or console. Sorry, because the slide is in the middle of this one. So they check the information that is on etcd. And the information that we have on etcd is just the information that we just provisioned before. So if you provision like 100 VM, this information will be set on etcd. We just give like a key to developers, and developers get this key, and they start their configuration by pushing their containers inside to the hosts that are defined on this JSON that is contained inside etcd or console. Okay? How do we create VMs? So we create VMs with Terraform, as you can guess. But we have a problem with VMware, with Terraform. Terraform doesn't give us orchestration possibilities. You do something, but then if you want to replicate what you do, you need to push, like we need to get our Git repo, and understand if what we have done, because we deploy so many VMs, and we need to relate what the project that we are doing with the Git repo location. Okay? And this association tends to be very difficult, because you have people deploying things and deploy several things at the same time. And then 6 months afterward, when we want to destroy something, we say, this thing that is on etcd, where it relates on Git. And this is difficult to find. So we create orbit, okay? And we will come to this later on. Another interesting thing that we do is monitoring. Okay, so we use Prometheus. Does anyone use Prometheus? Okay, yeah. Okay, good. So Prometheus is the implementation of Borgmon from Google. It fills our needs. In the past we used other things like Ganglias and these kind of things. I don't have anything against that, but it doesn't scale the way we want. Okay? And Prometheus does. Maybe other monitoring tools also scale, like Sensor probably will do. But we choose Prometheus. And Prometheus also gets information from this etcd. So everything we create with Terraform goes to etcd or console. So everything that's service discovery goes to this database and actually can replicate, and can understand what exists and what doesn't exist. So the etcd is our database of truth. Okay? If it's not an etcd, it doesn't exist. If it exists and that is not an etcd, something went really wrong. Okay? And the way that we do this Prometheus is very nice because we create like so Prometheus as a native service discovery mechanism, but actually you couldn't do it from etcd, so we end up to write our own mechanism to actually read things from etcd, put it in Prometheus, and Prometheus just gets all the infrastructure at runtime. So we just start in Prometheus, we give an etcd endpoint, and it discovers everything. Okay? So we ship our golden image with a node exporter, so Prometheus node exporter, and C advisor. Does everyone know about C advisor? It is, okay. So C advisor is also an interesting tool. They give us all these stats from the VMs and from Docker containers, so it's very helpful. And this is all on our Docker repo, which is Nexus. OTP, the Vault OTP. So the Vault is another HashiCorp product. It basically stores secrets, but it also stores like certs, SSL certs. So every time that we deploy a machine, we get this SSL cert from Vault, and this is applied to Docker API. And this is when we create the validity of 6 months after creation. But the Vault OTP, so we run new systems, but we still have like legacy systems that don't run Docker, don't run everything. They are just Java apps inside of VMs. So we push developers to try to move to the new world, what we call the new one. But there's still a road for them to go, so they need to find budget, and they need to find reason to tell a product owner that they need to go in a different way. And so we need to give them access at some point of SSH. So one thing that we clear with the golden image is that no one SSH in the system because you have Docker API. If you have Docker API, you don't need to SSH. Okay? And if you have access to the Docker API, you don't need SSH. So basically, for the old kind of systems, we let developers. It's a bit hidden, they don't know all the details. Only if they ask us, if they insist, we give them access to Vault OTP. OTP means one-time password, so you can provide them an SSH access, like for one time, okay, with a Vault token. And this actually goes to Active Directory and registers who enter and so on. So it gives us an audit perspective also. And all the storage is on etcd. So how we do persistent storage? So this is it's a complex subject. We don't have an answer for everything, but in terms of persistent storage, so we divide. So we have applications that don't require persistent storage, and we have applications that require persistent storage. Without persistent storage, it's very easy. You install the things, you destroy the things, you don't care what you just killed, because these applications can get stateless. If you need persistent storage, then we have an issue. Okay? And how did we solve this issue? So we solve this issue in 2 ways. So we have the independent disk flag at creation time. Independent disk creation is based on a specific hypervisor definition, so it won't work with all hypervisors. Okay? But it works on VMware in a massive way. And because we use vCloud there, if you want to go to a new territory, you can use vCloud there where we have the hypervisor. So, but yes, it's not fully scalable as we want it. We still have a problem with this. And we also use the VMware Docker driver. So we can deploy the Docker driver as a volume driver on Docker, and these have access to the storage that is on the VMware on VDC or vSphere platform. So in Terraform, destroys not separate resources tended before. So when we create something, we tell Terraform we create independent disks in the independent way, meaning that if we change the VM, it just removes the VM, it doesn't remove the disks, and we can have persistent storage this way. So Orbit, I don't know how long I have still. Yeah. So Orbit, Orbit project. Orbit project is orchestration API around HashiCorp Terraform. It allows direct execution of planet-wide destroy HCL configurations from GitHub and Git. So it provides execution workflow, it wraps HCL configuration, tags, and metadata, and it creates Docker containers for job executions, and uses HCL configuration for template. So how it works, so we have an Orbit client. Actually, this is all the same binary, but yes, different modes. So we have the Orbit client, you have a Orbit server, which is on the center, and speak Docker API with these Orbit workloads. And you have a UI called Biosphere. So we are developing this at Sky. This is one of my projects, I would say, and it is all written in Go. It basically receives a request from, let's see if on the next slide I can work with them. Yeah, so the Orbit client just sends a request to Orbit server responds as a UID task. This UID task is then sent back to the client. The client then generates a password and stores this password on Vault with the key as the UID. So this means that now the server and the client, they know this UID and they can relate to a specific job. Right? Biosphere is the UI that manages all of this. So I will show some image, I think it's easier. So this actually, we use HCL for everything we do in terms of configuration or JSON. This basically, in this Orbit task, what we send to Orbit is a Git token, okay? My personal Git token in this case. I send a Git path, so we know now where is our stuff. There is a Terraform plan inside of it. I give them some metadata like task group or Git test, and I send a GF state path. This is the XD or console path. And I say, do an apply, or do a destroy, or do a find. So this is related to this JSON that is on the bottom. This is another one. This is templating. So basically, we can also templating things. And the nice thing, for instance, this one deploys things in VMware, but we have also to deploy things in OpenStack, and we have other Terraform that deploy on AWS. So meaning that with a new UI or with the JSON, you can deploy multiple providers with a minimum functionality. And you can template by, so this is the principle of our VPC. So developers will have access to this kind of templating, and they will be able to set up how many CPUs they want to create, how many, what's the size of the Docker volume and so on, and how many images or machines they want to create. So this is like a UI for it. This is clunky because it's not like that anymore. This was experimental phase. But so you can deploy things on OpenStack, TV services. This is one of our services, and you have on the bottom experiment test on GitHub there. So all these plans were executed and to be deployed to all of them. And what this gives us is a track record of what we have done in the past. And this is what Terraform can't give us, because Terraform stores things inside HCL files. Right? And we find a way to relate HCL files with Git and etcd or console. Okay? This maps our infrastructure. Okay? So this was an execution of something inside that container, which was, we deploy something with persistent disks in VDC, which is a vCloud there. Okay? And so we track, this actually uses a SQL database. You can use SQLite or MySQL, and we are actively doing this stuff. We also, so in terms of the Docker that actually executes these tasks, the Docker host, we can add more Docker hosts, so we do a round robin execution. So you can have multiple people deploying at the same time and using different Docker hosts, so the job can be executed inside. So the job is executed inside the Docker host, but the VMs that are created can be in vCloud or AWS and so on. So conclusion, DevOps post-challenge have changed. So we are not in that anymore. We fight for this. Sometimes it can be difficult, but we won this one. Legacy infrastructure still brings low operational work. That's something, if you have experience, you will see this. You can do a big change, but we still have to run the legacy stuff. And this might be something that you need to account for. Focus on API, rather run scripts. I have seen that this fosters innovation. If you build APIs instead of scripts, you see things making lots of sense. You start feeling people connecting their stuff together. Even if it's on the wrong way, you can correct it. With scripts, you cannot correlate anything, or it will be very difficult to correlate. So it's possible to go hybrid with several cloud providers, still maintaining on-premises model, but that's art and probably costly. Infrastructure as code is a must. We couldn't do this without infrastructure as code. Yes, workload, the balance of the workload is very important. You cannot expect to have just PAU on your team and everyone will be happy. My senior reliability engineers won't be happy with this. And we try to balance that workload between projects and BAU, so things become interesting. All the skills, independently of the skills, I noticed that working with motivated people is a must. Okay, if they are very good, that's great. But if they are not motivated, they don't help. The output might not go so fast as your team go. Yeah? We found that also. And yes, that's it. We are
Okay, thank you, David. Thank you very much. Who's got a question for David? Mr. Hardy.
DevOps as a product of continuous delivery. Most people would think that sentence should be the other way around. Justify, please.
Oh, I don't know if I have to, but I think that if you want to have a coherent, you can have several development teams doing different things, okay? But when you share the same infrastructure, the same point of infrastructure, DevOps needs to have a hand on that. Otherwise, it's impossible. That is what I've seen.
Okay, anybody else got a question for David? Right there.
Hi. In your last slide, you said that going hybrid is hard using several cloud providers. Could you elaborate? Why is that hard? Or to put the question another way, how far are we from commoditizing the cloud provider?
Yeah, no, I think, go hybrid is hard in the sense that if you want to run a system that is running on premises and you want to run it in the same way in the cloud, then it will be hard, okay? And have the same set of infrastructure and be able to actually balance things around one place to the other, I think that's not very easy, okay? And our experience, because we are not cloud native company again, and this means that software that you use in premises we can't use on the cloud. For instance, DNSs, we use Anycast, BGP routing. If you want to expand your way of doing DNS to the cloud, you can't do it, okay? Because you need to go with the endless conversation on the network and things like that. So all this needs to be accountable, you know? And when I say it's hard, it depends on the culture of your organization also. It's not only a technical aspect of it, it's organizational, it's culture, and it's also in the way some technical aspect.
Cool, any more? Any more? Okay. I've got a question actually. So Orbit, that's something you guys wrote, yeah?
Yeah, yes, we'll probably open source it next quarter, second quarter, maybe next year.
I didn't even ask the question. Sorry, there's one more question somewhere. Not yet.
Do you have charts or visualizations like Netflix do for this sort of scale of your operations?
Sorry, can you please repeat?
Do you have charts or dashboards to show visualizations about how things are being used and the number of rebuilds, the number of failures like Netflix do?
Not yet. We have something similar. So we had a couple of graduates. So because I wanted to have more time to actually work on this kind of project, but so we have the grants. So the graduates came to the team, so they didn't have like operational work to do. So that given the interesting projects to them. Okay. So yes, we have a dashboard that actually represents the information that we have on Activity in a dashboard. Okay. But it still lacks of lots of information that we want to see. For instance, the number of containers that we have in place, you know, like at what date some container will shut down and then pops up again. These kind of things, no, we don't have that information. But we already know how many VMs, how many compute, how much RAM each individual teams are using for their own infrastructure. And we can account them on that.
Awesome. David from Sky, I think better. Thank you.